Hello, everyone, and welcome to today's webinar, How to Analyze PIM Using Live Traffic Without Climbing the Tower. Before we get started, I would like to go over a few items so you know how to participate in today's event. You have joined the presentation listening using your computer's speaker system by default. If you would prefer to join over the telephone, just select phone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. Today's webinar is being recorded and you will receive a follow-up email within 24 to 48 hours with a link to view the recording. I would now like to introduce Roger Pahe, Senior Product Manager.
Thanks, Tina. Good morning, good afternoon, good evening, everyone. We've got a big audience today from several different countries. I was wondering if one of you could type something in the questions box and just let me know that you can see my screen and that you can hear me okay. Just want to make sure that the audio is working here. All right, Krishna, thank you. Thank you, JD. Good. There was a webinar I did a couple of years ago where I went 20 minutes into the webinar and no one heard me. So thank you for checking up on that. Today we're going to talk about how to analyze PIM using live traffic without climbing the tower, which is a pretty big promise. So let me get into it here. I have a very big question for everybody who's on the call, and I think you're here because of PIM. But the question obviously is, do you have PIM problems on your LTE network? And it can be something as subtle as just a little slope in your uplink that you might not be able to tell whether it's PIM or not, or that classic shark fin where it is severe and causing lots of damage to your throughput. And I think everybody on this call hopefully is concerned about PIM in their network and looking to find different solutions to help solve the PIM problem. So in today's agenda, if you do have PIM problems, I'm going to show you a three-step method to diagnose these problems. And when I say diagnose, I'm going through a few questions that you will normally go through in a PIM hunting exercise, which is, do I actually have PIM or is it RF interference? If it is PIM, is the PIM internal or external? If I do have PIM, what is my hottest transmitter in a multi-band tower, which can get quite complicated, as you'll see during this presentation. Sometimes PIM can be insidious and you don't know when PIM is happening other than looking at your KPI reports. And we're going to do all of this diagnosis with no tower climb and no site takedown, which I'll get into some of the details of how costly and time consuming that exercise can be. And if we have time towards the end, we're going to go through a couple of advanced concepts of doing distance to PIM with minor calibrations and doing some PIM hunting and troubleshooting. Both of these obviously require access to the rooftop to some degree. But if we can focus on today's presentation of diagnosing PIM and obtaining a lot of information about what you can do, that is where our focus is going to be today. And just to lighten up the mood during this pandemic, if you want to stay till the end, I'll throw out a question and the first person who answers it gets a $10 Starbucks gift card. So just a little bit of incentive and a little bit of fun while everyone's sitting at home in lockdown. And so I'm going to go through this whole scenario, but my request to you guys is to stay focused for me for 45 minutes. I'm going to deliver as much information as I can in this time frame, and it's a lot of information, so please take notes, please stay focused with me and be interactive. There's a questions box, and I think there's also a tab for chat But if you want to be interactive, please type in questions. We will be going through as many as we can throughout the whole presentation. Turn off your Facebook, turn off your COVID-19 news updates, no texting. Stay with me and just give me these 45 minutes. And I promise you I'll deliver as much value and information as I can during this time. So just a little bit about me. My name is Roger Pahe. I'm a senior product manager in charge of RF interference and coverage mapping solutions for telecom. I've been in test and measurement for over 8 years now, and I live close to Los Angeles. And just to lighten things up a little bit, during this lockdown 2 weeks ago, I'm going to ask. This is an aisle in my grocery store. What do you think should be stocked here? Let me see if I can see that. Yeah, this is the toilet paper aisle, and that was 2 weeks ago. And so during this pandemic, I always think these things are so funny how people react. But there are signs of us coming out of this pandemic, right? States are starting to look at opening up. Here's my biggest indication that things are starting to open up is this. So 2 days ago in my grocery store, I saw a stack of toilet paper. So people are probably either all stocked up or we're coming out of it, so people aren't panicking as much. So hopefully this all starts to fade as the weeks go by here. And I'm doing a little bit of pandemic dreaming. I'm a big Dodger fan, and normally in April and May I'd be looking at the start of the baseball season, but now I'm looking at an empty Dodger Stadium, which is not making me completely happy, but hey, it is what it is. But all right, let's go back into my presentation. Enough pandemic side notes there. What causes PIM? I'm gonna focus in today's presentation on the solution of if you have PIM, but it's kind of important to at least understand the basics of what causes PIM problems. And I think most of you on the call, if you are familiar with PIM, already know these basic concepts. You've got a transmitter. It transmits into an environment. The environment encounters a nonlinearity in the RF path. And so then we have PIM that nonlinearity reflection goes into the uplink of a certain band that you have on the tower. Often it's not the same band, but it could be the same band as what the transmitter is. So the basic formula is you've got a transmitter. If we're talking about LTE systems, these are all wideband transmitters, so 5 megahertz on up to 20 megahertz. You've got a nonlinearity, the interaction in the RF path somewhere, and then you get PIM. And so you'll see why I just kind of want to stay on that very simple equation here, because solving this problem requires us to look at both components of this equation. So if you look at the practical aspect of what causes PIM problems, right? There's two classifications. One is internal. So one of the things that's internal, that's probably the #1 thing that can cause a PIM problem, is if you turn up a new band in your network. And so turning up a new band, you install a new radio, you're installing new cables, maybe, and you have another transmitter in a different frequency where you didn't have that transmitter before. There's oxidation of internal components, cables, connectors, brackets. There's poorly made components that actually I think most of the major operators have weeded the poorly made components out. There are PIM ratings now that prevent components that are poor in PIM ratings to enter their network. So I think most operators are pretty good with this now. Some of the external factors, you can get metal oxidation on elements in the RF path externally. So things on the rooftop, any kind of metal that starts to oxidize on the rooftop or in the path of the cell tower. You've got new construction. So somebody puts up a billboard, somebody puts up some weird structure, and now you've got something in the RF path that you didn't have before. Or other operators turning up new bands. And anybody encounter any problems with band 14 in the US? It happens. And when you get new bands out in the environment, especially if it's another operator, you've got some problems to try and solve. All right, so if you do have PIM, you maybe have some degraded KPIs in your reporting, and you maybe are able to look at the uplink and you can see a shark fin or something like that. Let's talk about how to start diagnosing this. And so there's several questions that a person who has to diagnose this kind of problem has to go through. So the first is, and I've gone through these questions before, is PIM present or is it just RF interference? And sometimes you can tell, and many times you can tell, but sometimes you can't. Is it internal or external? Which bands are contributing most to my PIM, which relates to how you troubleshoot the PIM. So it's important to know which bands are the major contributors. Is my PIM occurring intermittently, which can make it very difficult to try and debug this, especially if it's at particular days or particular hours where the environment is in a state of flex. So you maybe have a venue where people are driving in and out. And then finally, distance to PIM. At the end of the day, you'll kind of want to know if you can do an analysis on distance to PIM. I have a little asterisk here because this requires something that you need to attach onto the antenna. So I'll talk about how far you can get with analyzing PIM without going to the distance to PIM, and then we'll talk about how to do that easily. What about multiband sites? And I'm sure I have most familiarity with the networks in the US. Multiband sites in all of the large metro areas are, I don't know, way more than half of the towers that are out there, the macro site cells that are out there. Multiband sites have a very interesting problem because multiband PIM problems are multi-complicated. You get a number of different intermodulation products or IM products that can crash multiple different uplinks. So it's very important to understand that in diagnosing PIM for a multiband site, you have to understand which downlinks or transmitters are the main contributors, which frequencies do we need to troubleshoot with. There's always a question I get is, will CW PIM testers give me accurate results versus real world wideband signals actually causing my problems? The answer to that question is it depends. And it depends because if there's single frequencies in the wideband transmitter that are interacting, then the results will mimic a CW PIM tester. But if the wideband interaction is giving you wideband IM products, then the analysis across the wideband actual real traffic is going to be more accurate. So there's a couple of different answers to this question based on the nature of PIM. But if we look at, there are methods today that work, right? But they're a lot of work. And so if you encounter PIM problems right now, you're normally looking at, okay, I kind of know it's PIM, now I got to go debug it. You're looking at a very invasive solution. So you need to turn off the site or the sector, right? Assemble a tower crew depending on where the antennas are located. You disassemble the RF cabling, and now you're really getting invasive, right? You connect your PIM tester, which sometimes you can take an educated guess on the test frequencies. Sometimes you have to do an iteration to find the appropriate IM products. If the PIM is intermittent, you got to arrange everything together when the PIM happens so that you can do the analysis at the exact time or time of day that the PIM actually occurs. You need to do a distance to PIM measurement, determine if it's internal or external. If it's internal, you kind of bang on the cables, which is a sort of industry term, maybe check the torquing. If it's external, you use a PIM hunting probe like I show in the picture here. It's pretty invasive. And I think at the end of the day, sure, it's a lot of work. There's another side of this coin, right? Which is the same coin, which is the current method can be very expensive. I mean, you're talking about paying a tower crew. And again, these are kind of just generic US numbers. I know we have people internationally on this webinar. The tower crew per day, 5 to 15K per day. You have cell site downtime, which depending upon the site, right, can contribute to the poor quality of service. I mean, it has to push traffic out to the other sectors. You have to overload some other bands that you might be able to maintain it active. You've got to pay for the operators, technicians, and the RF engineers' time. You've got equipment for multiple bands. And you could have multiple days of diagnosing and troubleshooting depending on the severity and depending on how insidious and depending on, sometimes you cover and are able to mitigate one source and it uncovers another source. So you could spend days with a tower that's down. That's in the extreme case. Okay, a little bit of pandemic humor. And now is meeting with a cell crew hard because of the lockdown? I found this interesting. It's a very serious problem, so I don't want to make too much light of it. But some of the 5G cell towers being set on fire because of the coronavirus conspiracy theories. I'm sure everyone on the call has been in the industry for a while, so you probably hear news about stuff like this. So a little bit craziness in the world and a little bit of danger especially if you're in the UK, of going to a particular cell location. But you know, things are in lockdown right now, so sometimes you can't get to places. So let me talk about an easier way than the method that I just described. Is what's needed for a multi-band PIM analysis, right? We want to analyze PIM, and we want to know and answer the questions of how to diagnose it. We need to know where the transmitters are, obviously, so we need to know the downlink transmission frequencies, the timestamps. We need to be able to look at the uplink and see how that reflection is coming back into the uplink. We need the ability to look at all of the bands simultaneously, and we need to be able to control the radio power, which is going to give us those IM products in very clearly. There's only one place that all of this stuff is available, and that place is on the CPRI link. And so we're going to look at a scenario where we use the CPRI link to do a multi-band PIM analysis to answer all of the questions on PIM diagnosis that I just talked about. So let me go through a little scenario here. And this, again, is a US sort of centric example. If I've got a tower and it's got a 700 megahertz, whatever, lower band, higher band, band 14, AWS and PCS, there are a number of different IM products between all of these frequencies that can interact in different uplinks. If there was a way to hook up to the CPRI link, and so for those of you who don't understand what the CPRI link is, it's just a communication link between the radio head and the base station. So if we can tap into the CPRI link, we have all of the data we need to simultaneously do a multi-band PIM analysis. And so in doing that, we can answer all of the questions that I've been talking about. So let's look at a scenario where we can do that. Here are my 3 bands up top of the tower. The radio heads connect through the CPRI link. If we can tap using an optical tap into that CPRI link, maintain the communication of the entire network, and then use the downlink and uplink data to do our PIM analysis, this is the ideal scenario. And this is a product that we're introducing called the IQ Fiber Master, is to be able to do that multi-band PIM analysis without having to do the tower climb and be able to do that multi-band PIM analysis. So let's get into this a little bit. It's the only tool that can do a full PIM analysis without climbing the tower. It runs a full PIM analysis, giving you whether PIM is present, internal or external, distance to PIM, which I'll talk about with that caveat that it needs to do a calibration, multi-band, multi-sector PIM analysis, and PIM monitoring, all in one box. And so we use live traffic for this, and we do it without taking down the site. So if we're able to use this solution, I can kind of boil this down into 3 different steps. And so here's a simple connection diagram using an optical tap with the uplink and downlink on a single band. The solution consists of 4 parts. The first part is a sensor. The second part is the software on a laptop. The third part is the optical tap, which many vendors already have, many operators already have this as part of their network. And then fourth is a calibration PIM diode, which I'll describe in doing the distance to PIM calibration in just a second. All right, let's take a look at the solution. And when we diagnose PIM, it's just a simple 3-step process. So let me go through those steps. Step 1 is determining if you have PIM or RF interference. There's 2 sub-steps within this. A lot of times operators, I don't know of any operators in the world who don't have KPI reports that they can look at. PRB heat maps versus time, something that tells them that there's something going amiss with their environment. Some operators are better than others and are able to do some kind of power analysis where they can turn up the OCNS or AILG remotely and create KPI reports from there. So this will give a lot of operators a lot of information initially on what it might look like and what kind of problems you might have. And sometimes from these you can determine whether you have PIM just from looking at them. If you don't quite understand from the KPI reports whether it's PIM or not, you can use the IQ FiberMaster and run a PIM analysis using the CIPRI data. And so the analysis shows you if I have PIM, how severe it is, and whether it's internal and external. Let me go into that in a little bit more detail. The PIM level is a degree of severity, and you can set the thresholds according to your own network requirements. But if you're able to look at multiple uplinks and multiple downlinks and have PIM reporting on each uplink, there's a model and signal processing model that you can use and that the IQ FiberMaster uses to determine the PIM level. And so in this example, it fails because the PIM level is too high. It identifies the PIM source as external versus internal. And it gives you, this is a different way of looking at PIM, and it goes a little bit lower than a KPI number. So the RX desense. So in the uplink, how much is my antenna desensitized according to noise floor rise that's due to PIM? So it's a pretty useful number when you get down to looking at KPIs at the next level of seeing how much desensitization you've experienced according to PIM. So you run the PIM analysis, you get these initial questions answered, and then you can take it to step 2, which is analyzing which transmitter is contributing the most PIM. And so this will help you understand, obviously in that multiband scenario, do I have transmitters that are contributing more than others? In this case, I've got 2 transmitters that are affecting this 709 number 1 uplink. It's the 739 transmitter and the 763 transmitter. And so now you know when you go to your troubleshooting phase, oh, well, I need to focus on these 2 transmitters because those are the ones that are contributing most to my PIM. So you can look at this graph, which is a report that comes out of the IQ FiberMaster, and you can examine the results in sort of a heat map summary, plain English as well. So that's step 2. Now we've answered a couple of different questions, right? We've answered the basic questions about PIM. We've answered which transmitters. And then you can go to a 3rd step. The 3rd step is doing a distance to PIM analysis. Now this step, you do need access to the antenna. So whether you need a tower crew or you can climb up onto the roof, you need to attach the PIM diode or a PIM source right onto the antenna and do a calibration exercise. After that, you can redo the analysis with the high power turned on the radio head and determine whether your distance to PIM is positive or negative and what the exact location is. If you don't have access to the antenna, there isn't any way to do this distance to PIM diagnosis. So you're maybe a little bit blind, but you're still way ahead of the game because you've been able to do the first two steps and determine whether it is internal or external, and determine how much of the desense you have and how much of each transmitter is contributing to your PIM on any particular uplink. So this is the diagnosis phase. Now, there's a fourth step here, which I'm calling optional, is what if I have intermittent PIM? And so you normally, well, I won't say normally, PIM sources can be kind of insidious. They can kind of be tricky. Intermittent PIM can be very tricky. It doesn't happen all the time, but if it happens a lot in your network, monitoring PIM is one way to see when PIM happens and how severe it can be. And so you can use the IQ Fiber Master to stick into your hut, leave it there for several days or hours or whatever, and examine the graphs over time. And so in this particular case, we've got a number of hours recorded in this graph, and you can see at certain times the PIM will spike. And then you can use your troubleshooting techniques when you, at these particular times of the day, when you get to that point of troubleshooting. Okay, so that is an optional step again, and we your PIM may be consistent, so you don't need to do a monitoring. That was interesting. I just got muted somehow. All right. So here's a summary. You diagnose the PIM by connecting the IQ Fiber Master. Is it present? Is it internal or external? You analyze the PIM for what transmitters and what cross sectors you can look at. You do a distance of PIM analysis if you have an access to the antenna. And then optionally, you do PIM monitoring for intermittent PIM. Okay, so now we've got all of this information about the characteristics of our PIM, right? So the question is, now that you've diagnosed PIM, what's next? And so I don't have a whole lot of time in going through a whole troubleshooting phase. That's probably the subject of another webinar, but let's go through in some of the things that you can do and you might be able to do without climbing the tower. So in this graphic here, I've kind of broken out the flow into the diagnosis phase and troubleshooting phase. And so we just went through a whole diagnosis phase where we understood the frequencies that are causing PIM, whether it's internal and external and so on. We've been able to monitor it. If you have access to the antenna, we've been able to do a distance to PIM calibration. We can now provide all of this information to that whole troubleshooting phase. And again, if you remember, we have two types of PIM. There are internal PIM and external PIM. And depending on what the diagnostic information has told you, you can go to one or the other. So let me dive down into these two different areas, and then we can talk about some of the things that are easy and some of the things that are hard. So the internal PIM troubleshooting, right? We know it's inside of the network somewhere, and we're sure of it because we've done the PIM analysis over CPRI, over a multiband scenario, and we're comfortable that it is internal to our network. You can bang on the cables, which I don't recommend these days. A lot of technicians like to use this term, but I don't personally like to use that, but sometimes that's the way people talk. You're checking torque, really, right? You're checking your connections. You're replacing cables or components. Maybe you have to replace a bad component, like replacing an antenna, for example. I do think operators have a pretty good handle on having quality control on their antennas and components. So normally it might be just a bad connection or corrosion that's happened versus having a bad component, but you never know. Sometimes poorly tested components that may be properly PIM rated are entered the network somehow. Checking your torque on all of your connections. So again, the nature of PIM is that non-linearity. So the quality of the connections is a big deal, and the quality of the cables. But the easiest part for non-linearity is to enter a scenario inside the network is at the connection points. So connectors, any kind of metal sliver that might have entered into this can cause that nonlinearity. So I think in terms of, now, do you have to climb the tower for this? Well, yeah, you do. But at least you know that it's internal and you're not going on a wild goose chase across different places and different things. Your site might still be live, but you've just turned off the sector so that no one gets radio burn. So there's, again, just follow the safety protocols when you get to this point of troubleshooting internal PIM. Follow your safety protocols so that, and everyone's got them. So I'm not saying anything that anyone doesn't know here. External PIM troubleshooting can be a little bit more interesting if you're using a solution like the IQ FiberMaster. Let's look at this example here. Let me see if I can pull up a little pen. My antenna location is right here. So if you can see that little red dot, the antenna location on this rooftop is right here. If, for example, I've done a distance to PIM calibration and I can see that I've got 25 feet on my distance to PIM, I can look at that radius right in front of the antenna and perhaps see if there's some item that's right around that area where I can mitigate with some PIM blankets, for example, and do a retest to see if that was the source of my PIM. If you've got an area where maybe it's further out and you've got a 60-foot distance to PIM number, now you're looking at something further and you might see some metal casings that might have oxidized, some metal on the edge of the wall on the rooftop that might have oxidized. Hopefully you're not looking out here, but although the source may be out here somewhere in the exterior where there's some item in the environment that's causing that PIM, which will be easier to look for. In a rooftop scenario, this example is easy, right? You don't need a tower crew. You can find maybe areas that are 25 feet in radius from the antenna, or maybe even 60 feet in radius. So a tower crew isn't necessary if you're careful in following your safety protocols. But on a macro cell, you may have to call up. But at least in a macro cell scenario where you have a distance to PIM calibration, at least you know it's external, not internal. And so you're not looking for something you're not on a wild goose chase. You're looking for something specific and looking at mitigating something specific. So, and again, this whole area of external PIM and troubleshooting is a subject that's is a whole new webinar, and people have talked about this for years. So if you've been in the industry for a while, you know that there are a lot of methods to do external troubleshooting. Okay, I think all of you know, looking for metal anomalies, clean up the rooftop using a PIM Hunter probe. So if I look at the entire flow from doing a diagnostic phase to troubleshooting phase, the IQ FiberMaster is a new product, and it gives you that diagnostic data. That diagnostic data can then be taken into the troubleshooting phase where you're using things like our PIM Master, our Spectrum Master with the PIM Hunter probe, so that it can you can locate the exact nonlinearities on the rooftop or in the environment that can be causing your PIM. Okay, a couple of extra things about the IQ FiberMaster. It is small and light and compact. It is using the CPRI link, so it doesn't need its own amplifiers. It doesn't transmit RF, and it's multi-band. So this little box can handle all of the LTE bands that are in existence today. And so I took a picture of this in my living room because I'm in lockdown, as all of you are. The case, which encloses the optical tap, and the sensor is all encompassed here. And here's the size comparison with my 14-inch laptop. The size is actually quite light. So, all right, let me summarize this, and then we'll get into a little bit of fun here. So the IQ FiberMaster is CPRI-based all-in-one RF and PIM analyzer. It'll diagnose your PIM problems, whether it's just RF interference or doing a full PIM analysis, which could include a distance to PIM calibration if you can get access to the antenna. It can monitor intermittent PIM. It uses real traffic because it is the CPRI link. So it's non-invasive, meaning the site remains operational, and it's using the real traffic, real live traffic. So the accuracy is real world accuracy versus using tones that you have to use in the troubleshooting phase. Supports all of the LTE bands in one sensor. We support all of the major equipment manufacturers: Nokia, Ericsson, Huawei, Samsung. I think that covers North America. Maybe ZTE, which, let me know if you use ZTE in your network. I can check on this for you. So a couple of extra things that I didn't get into. CPRI operates, as you probably know, on different line rates. We can go up to line rate 8, which is 10.1 gigabits per second. It's got the ability to look at multiple downlinks. So we can do 4x4 MIMO support handily, which is a big deal when you start to talk about multiple transmissions in the same frequency. We don't need a certification in order to operate this. There are some localities where you're not able to transmit signals outside of the band. So even though, let's say you've got a scenario where the 1800 maybe is clashing and throwing an IM product in your 700, and you need to transmit, but you don't have a particular frequency, so you're using maybe another operator's frequency, it won't transmit outside that band. So because we're using the radio head to transmit. And then it's small, light, and compact, less than 10 pounds, very easy, very simple to use. You can leave it in the hut. So did I fill today's promise? If you have PIM problems, I'll show you a way to diagnose your PIM, whether it's PIM or RF interference, internal or external. We know the hottest transmitter in a multiband tower. When is PIM happening? There's no tower climb to do this. There's no site takedown. Well, let me do a little caveat there. You need to get the optical tap into the CPRI link, so you might need to take it down for 2 minutes to install the tap. So hopefully that doesn't, yeah. So you do have a 2-minute little downtime here. And if you do have access to the antenna and you do have access to doing a roof climb, you can do a full distance to PIM calibration so that you can do a distance to PIM analysis. And then I went over some PIM and hunting and troubleshooting scenarios that, again, does require a second webinar. And let me know if you guys are interested in doing a webinar or on some of the PIM hunting where I combine using data from the IQ FiberMaster with the PIM master and to do a full-blown external PIM analysis and internal PIM analysis if that's where your PIM is. Okay, so second to last question for you guys. Do you have PIM problems? And if you need help diagnosing and troubleshooting them, please contact your Anrtisu salesperson and they can help you out with figuring out how the tool can help you. If you don't know who your Anrtisu salesperson is, you can contact Kim Masoner, our very capable and competent marketing program manager. And here's her email. If you don't know who your Anrtisu salesperson is, she can redirect you to the right person. Okay, all right, let's have a little bit of fun towards the end of this webinar, and then we'll take some questions and answers. And so who wants a Starbucks gift card? Let me pull up my chat here. Yay. Wow, there's a lot of questions. Holy cow. We're going to get to those questions in just a second. But if you guys could type into the chat, who wants to, and hopefully Starbucks is still operating in your area. I had, let's see, at least 10 Starbucks in my locality here, and only one of them is open. But it's open and I can still go there. So who wants a Starbucks gift card? Yes, yes, okay. Eric, Michael, thank you. Jim, John, thank you. Krishna. All right. It's whoever is going to be first to answer this question and type it in the chat just where you were typing the yes. Okay, here's the question, and the first person who answers this gets the card. Okay, here it is. You guys ready? Okay. Oops. Sorry. All right. In my PIM equation, I had PIM equals TX plus NL, right? All right, here's the question. Here's the question. What is NL? All right, go. Somebody type it in. Let me see if I can get there. Oops. Where'd I go? Okay, I'm good. No, it's, oh, Cole, you're so close. Oh, NL. Oh, somebody else who typed it in. Let's see. Nonlinearity. I see Orlando. Orlando, you and I just I'll type in the chat your email address and I'll get to you because if something else works easier for you than a Starbucks card, well, I'll have a chat with you on that. All right, guys. The PIM term, or the RF term that's used in this, is PIM is equal to a transmitter. So you have two frequencies interacting with each other on a transmitter, and then you have the nonlinearity. So the transmitter interacts with the nonlinearity, and then off you go, and you get PIM, and then you need the IQ fiber master. All right, that is my last question. Now I will leave questions to you guys. So Tina, did you want to read through the question and then I can answer them? Is that the easiest way, I think?
Sure. Thank you, Roger. We will now begin with the questions. So let me scroll back up here. Sure. Okay, the first one, is it important if IM3 falls outside my band?
No. So if IM3 falls out, well, let me clarify it. If IM3 falls outside of your uplink, you should never see it. So it's not important.
Okay, our next question. Has Anrtisu worked with Ericsson to ensure Anrtisu and Ericsson stay current with Ericsson's CIPRI links and software updates? Ericsson is notorious for changing CIPRI and not sharing with vendors what the changes are, thus rendering test equipment useless until the vendor figures out the Ericsson CIPRI changes. And this is from William Ward.
Who asked that question?
William Ward.
Okay, William, thank you for that question. You obviously know the industry. I will tell you that Ericsson will not work with anybody, so we're the same as everybody else. But a few years ago, there was, so in CIPRI, it's all bits and bytes. The non-proprietariness of Ericsson comes in the way they arrange the bits and bytes. And so if you can figure out the way they arrange the bits and bytes, that is the key, right? So there are two things that we do at Anrtisu at the moment to help us overcome Ericsson. One of them is they have formats that are already out there in their network, and we go to as many towers as we can. We collect the data, which is really capturing raw CIPRI, and make sure we can work. And we're pretty comfortable where we are at this point. There's a second thing, which is a little bit more proprietary, that involves a signal processing bit analysis, for lack of a better term. we will come up with a signal processing bit analysis where I don't care what they're going to throw at us, we're going to automatically be able to decode it. It's not out in the product yet. It's something that's being discussed, but we know how to do it. So hopefully that answers your question, and you are absolutely correct. If Ericsson decides to start to use their own protocol that's not even CPRI tomorrow, that's a tough one for us. But the good news is they use CPRI, relatively standard. We can keep up with them as long as we get enough exposure, and we're going to be able to overcome it longer term with our signal processing algorithms.
Okay, our next question. Do you not have to take the site down to install the optical tap? Most sites
Yes.
I visited do not have them installed.
Yeah, and so hopefully I answered that question towards the end of the presentation. You do have to take the sector down according to your own processes and procedures, but normally it involves locking down the sector, inserting the optical tap, and bringing the sector back up. And that process, if you have everything ready, normally takes about 2 minutes, depending on the number of fibers. But yes, you do have to take the site down for, it's really minutes, maybe seconds, but minutes.
Okay, next question. What is the time to install the optical tap? During this time, the sector will be out of service.
Yeah, if you're fast and you know what you're doing, it's probably less than a minute, but I will say 2 minutes on average.
Okay, can you show, can you bring up the last slide again? Somebody wanted to take a snapshot.
You guys can have this presentation.
Yes, as I mentioned, in case you join late, you will get a follow-up email with the recording. Okay, let me get to the next question as we're doing that. Can you tell if the uplink energy is PIM or real traffic from your CPRI tap?
Yes, we can. There's a signal processing algorithm we use that's proprietary. And yes, we can determine whether it's real traffic or the power levels are due to PIM.
Okay, next, how long do you recommend running tests in intermittent PIM cases?
The first thing I would do is probably look at your KPI reports. If you have access to a PRB heat map, so the physical resource block heat map, that would be
per day.
first.
Per day.
Yeah, and if that gives you a clue across a day or a week, that's probably what I would do to try and find intermittent PIM, is to go off of that as your initial filter.
Okay, the LQ works with Huawei or ZTE nodes?
Yeah, we work with Huawei. I have to look at ZTE. So I'll have to probably contact our China team for that.
Okay.
Who asked that question on ZTE?
That was Jose Guerra.
Okay, so, okay.
Does your IQ FiberMaster support eCPRI for 5G or greater?
So we are watching eCPRI. If you're familiar with the specification, there's different options within eCPRI. We are fully planning to support the option that's carrying IQ data. There are options within eCPRI that does not carry IQ data. It carries packetized demodulated data. And obviously we can't look at PIM with demodulated data. So we are fully planning to support that. And let me know if you see eCPRI out there. We are only planning to support it on a major rollout, which we haven't seen yet. But we're prepared and ready for eCPRI.
Will it be on the roadmap for 2600 megahertz band?
Yes. So the good thing about eCPRI and CPRI itself is it's baseband. So we don't care what the frequency is. So yes, it will support all of the bands, including the 2600.
What about 600 megahertz?
Yep.
Okay.
Ooh, somebody from T-Mobile maybe.
550 megahertz works this frequency? Same person.
Yes.
Yes, okay. What is the ratio of the optical splitter 10/90?
Yeah, we're using 70/30. That has worked with 100% of the network equipment that we've gone to today. And so it's very dependent upon obviously the network equipment manufacturer's optical specs and their SFP specs, but we found that 70/30 is quite a good ratio to go to market with.
And then support for multi-mode CPRI?
Yes. So I think I understand the question. Type in another. Who asked the question?
That was from Daniel Carpenter.
Daniel, if I don't answer your question, please re-ask it. But I think you're talking about the type of fiber, and so the type of fiber and SFPs. We have the standard SFP support, so we can support single mode SFPs and fiber and multi-mode SFPs and fiber, and as long as the rate is 10.1, so rate 8 or below, all of that is supported. But if I didn't answer your question, Daniel, retype that question in if it doesn't have to do with the type of fiber.
Okay, and then in the list of brands of equipment supported, are all models included?
Yes, so let me that's a really good question. Who asked that question?
Martin Lima.
Thank you for the question, Martin. The all of the models are supported on the LTE bands. You might get a scenario where you've got UMTS or GSM or maybe a 3G scenario. So the product supports everything LTE and nothing everything else. So UMTS or GSM, those bands are not supported. But if you look at all of the LTE models, yes, all of the LTE models have tested as much as we can. So.
Okay, I think, okay, here we go. Martin Lima, back to Martin, or is it necessary to check the model or soft revision before going to the site?
What I recommend, and Martin, you and I can talk offline too, because there's some detailed questions here, but what I normally recommend is doing a site assessment before you go to the tower. And so a site assessment meaning, well, how many bands do I have? And how many fibers do I have? And how many antennas per radio head? What's my CPRI rate? And sometimes you can't get that, either just that information isn't available, or you got to go to the tower and look, oh, it looks like single mode fiber, for example. And so if you can do that initial assessment, it certainly reduces the amount of time you have to spend at the tower. You have the right fiber and SFPs, so you can plug them into the sensor. You know that you're looking for the 700 megahertz and the 1800, for example, or whatever bands they are, and then you have at least an idea of what the tower looks like. I always recommend doing that before going to a site that you're going to plug in something like this. Hopefully that answers your question, but contact me offline and we can go through some of the details of some of the intricacies of hooking up this type of product into a CPRI network.
Okay, do we need to buy the software separate?
No, the software is included with the sensor. The options are the optical tap and a couple of PIM analysis options. One of the PIM options is to just do the PIM analysis itself. And the second option is to add monitoring, which many people may or may not need, but it's there in case it's necessary.
So it changes the measures on the too high humidity countries? I'm not sure. Michael Ars Not sure if that makes sense to you, Roger. So it changes the measures on a too high humidity countries.
No, high humidity should not affect our equipment. If it affects the radio equipment, you'll see that reflected in the transmit and uplink. So you're still getting the real analysis of what's real versus, yeah. So I can't comment on the radio performance in high humidity environments, but our stuff will be just fine.
Okay, we have just a couple more. For external PIM hunting, do you need band pass filter?
For external PIM hunting, yes. So if you're doing a troubleshoot, and this is, it sounds like maybe I'll do a second webinar on the actual troubleshooting, but you do need a very precise tone and a very precise spectrum analyzer that's calibrated to that certain IM product's frequency so that you can find the exact location of the nonlinearity. Hopefully that answers the question.
Okay, and then the last one I have in here is, does a calibration PIM diode come with the IQ fiber master?
Yes, yes. It's actually, I mean, at the end of the day, that PIM diode, and if you're familiar with RF, you know, the PIM diode is a very strong PIM source, but you can use other strong PIM sources like, you know, a ball of steel wool. But yes, the PIM diode does come with the IQ fiber master.
Great. So that was our last question. So I want to thank you very much, Roger.
You're welcome.
And on behalf of Anrtisu Company and our presenter, thank you all for joining us today, and have a great rest of your day. Thank you. This
Right.
concludes our webinar.
Stay safe, everyone. Thanks.